So here we have a very interesting problem from the concepts of circle. You can see there is very little application of limit here. So just go through the problem statement and then we will solve the question, give it a try, then look for the solution problem. So the given question says we have a circle, a radius 1, the line is tangent to the circle. Then another circle is drawn which is tangent to the line L1 as well as the x-axis. And this process is repeated n times. We want to find the value of the x-intercept of that line, basically. So let's solve the problem. This is how the diagram of the question will look like. These are circles. These are repeatedly drawn because it's not possible for us to draw all the circles here. That will be very hectic job. See, this will be another. There will be another such circle, and this will be continued. So let us consider for circle CN. That should be CI. Let's for circle CI, AI comma 1 be the center and it touches the line LI and LI plus 1. So you can write the equation of ln in terms of slope intercept form. We're considering that the line LI is intercepting the x-axis at xi comma 0, and since it passes with the point P, given point P 0 comma 4, we can write the equation of the line Li in terms of xi and 4 using slope intercept form. That's very basic concept from straight line. So we have written the equation of Li. So this again should be Li. Li. Now we'll apply condition of tangency to Li and Li plus 1. Let's assume that the center of the circle Ci is ai comma 1. And we all know the concept of condition of tangency, but here we are going to use a brilliant concept that's usually not taught in the regular classes. So let us apply condition of tangency for the line Li and circle Ci. Li and circle Ci. The given equation of line was xi, x over xi. Center is so we'll write mod of root over of 1 over xi whole square plus that was 4, that will be 16, 4 square 16, 1 over 4 square, and here will be a, here it will be ai over xi plus 1 comma 4. I guess I'm writing correct. It's 1 comma 4 minus of minus of 1. That's equals to the radius of the circle, and this is condition of tangency. Now the important question comes that how will we determine the sign of this modulus? How will determine the sign of this modulus? See, for this we are going to use a very interesting concept, and that's the key point of this entire question. For a line, there we have a point, say P, and there is another, this P point is the known point, say this is Li, say this is Li, this P point is some known point, and this is the center Ci, this is the center of the circle Ci. Now here what we did, we have put the value of Ci, the coordinates of Ci, Ai, comma 1 in the line Li, and we want to determine the sign of this mod. So how do you do this? See, the concepts of straight line tell us if P and Ci are on the same side of this line Li, then we can write that Li Ai comma 1. That means the value of Ai when we put the value of the line Li when we put the coordinates Ai comma 1 multiplied by Li P. If this is greater than 0, then this point and this point are on the same side. If this is less than 0, then this point are on the opposite sides of Li. So now, if we consider P, as I said, was a known point for us. If we consider P as the origin, that's 0, 0, 0, 0, what will be the value of Li? That is Li, here we put, see, 0 over xi plus 0 by 4 minus 1, that is negative value. Now, whenever we all know from the diagram, let's move on to the diagram. For circle Ci, these are the two lines. This is Li and this line is Li plus 1, Li plus 1. And there's the origin, 0, 0. We can clearly observe this is the center. This is the center Ci. This is the center Ci. That for Li, the center and 0, 0 are on the opposite side. And for any Li, this is negative. That means for any Li, when we put the value of origin, this is negative. And they are on the opposite side. That means what? Li, when we put the value of Ci in Li, that is the center. When we put the coordinates of center into L 0, 0, because the value of L 0, 0 is negative, and they lie on the opposite side. They lie on the opposite side implies this product is negative. This value is negative, implies that Li Ci greater than 0, greater than 0. So what we can conclude for this value will be greater than 0. This value will be greater than 0. Since LICI is greater than 0, this value is greater than 0. This value is greater than 0. So here simply we are going to open the modus AI minus 3 by 4 root over of 16 plus xi whole square. It's 4 divided 4, 4 multiplied 4, 4 multiplied. This value is positive. The value of square root is always positive, so we don't need to bother about that. This will give us 4 times ai, 4ai minus 3. I think we missed something. Okay, sorry. This will be xi and there will be xi. So we missed that. This will be 4xi, right? Fantastic. 4xi. So this is going to be simply 4ai minus 3xi equals to, or we can write simply root over of 16 plus xi whole square. Now we go for the line Li plus, this will be Li plus 1. What I was writing, this will be Li plus 1. Li plus 1. Fantastic. For Li plus 1, this value of mod, when we are going to open this value of mod, Ai over xi plus 1 minus 3 by 4 root over of 1 over 16 plus 1 over xi plus 1 whole square, that is going to be 1, and this value, I think this value we concluded to be negative, right? Because this value should be negative. Let me explain it here. This is negative, this is going to be negative, sorry for the mistake. This is going to be negative because, let me show you just once, we'll get one more explanation. This is the circle and this is the line Li plus 1. This is the center 0 comma 0. When we put Li plus 1, the value of 0 comma 0 on this line, what we have a negative value, and the center and this lie on the same side. That means when we put the value of the center, that is Ai comma 1, we are also going to have a negative value, because they lie on the same side. So this is going to open with a negative sign. Just transfer the sign there and write the simplified form here. This is equals to 1. Here we will have 4 Ai minus 3 xi plus 1, 16 plus xi plus 1 whole square. There will be a negative sign, equals to 1. Fantastic. Now what's our second step? We'll add these two equations, which will give us a kind of a recurrence relation. After adding these two equations, we'll get this kind of a recurrence relation. This 3 is coming. I think we committed some kind of calculation mistake. Oh yeah, 3 is here. These 3, when we add them, this 4i and 4i will get cancelled out. 4ai and 4ai will get cancelled out, and then we'll have this kind of expression. Now proceeding with this kind of expression, we can clearly see that this is a kind of a recurrence relation. What is written here? This is good. Difficult. I plus 1 minus I, right? So this is a kind of recurrence relation. This will be I plus 1 kind of recurrence relation, and we all know that recurrence relation is not there in JEE syllabus. So let's go to the first line. This is P. This circle's center we all know 1 comma 1. Using condition of tangency, find out this value of x1. This is 3. Don't miss this calculation, because calculation is very important. It will help you to understand the problem in a better way, as well as sometimes JEE papers like JEE 2022 paper was very calculative one, so we should not skip calculations. This x1 value will be 3. Here we have written center of C1 is 1 comma 1. Applying condition of tangency, that's COT. We have the equation. We get the equation as x by 3 y by 4, x1 equals to 3, right? X1 equals to 3. From this, here we can put 3 times of x2 minus 3 root over of 16 plus x1 square, that's 16 plus 3 square 9, that's will be 5, plus root over of 16 plus x2 square. From this, find out the value of x2, calculate the value, pause the video, calculate the value. You will get the value of x2 as 15 by 2. Similarly, find the value of x3, because for any kind of pattern, to find out any pattern, at least we need 3 terms. So we find out the value of x1, x2 and x3. Now let's try to observe the pattern. Let us write them in an organized way. x1, x2 is 15 by 2. X3 is 63 by 4. We can clearly observe that this is 2 to the power 0, 2 to the power 1, 2 square. So this is going to be the xith term is going to be 2 to the power I, and this 3, 15, 63, that's 4 minus 1, 16 minus 1, 64 minus 1. 64 minus 1 means what? 4 minus 1 means 2 square minus 1. 16 means what? 2 to the power 4 minus 1. This means 2 to the power 6 minus 1. That means xi term is going to be what? 2 to the power 2i minus 1. This is 2, right? So this is the value of xi that we are getting. This is the value of xi that we are getting. Then we use limits. This value can further be simplified as 2 to the power I, 2 times of 2 to the power 2i minus 1. What we have been asked to find? X over 2 to the power. Limit n tends to infinity. So xi over 2 to the power I, limit I tends to infinity, will be 2 times of 2 to the power 2i minus 1 by 2 to the power 2i. Those who don't know limits for them. 2 to the power 2i minus 1 over 2 to the power 2i. This value is tending to infinity, then it means this value tends to 0. This value is 1. So you can write this as 2, which is our required answer. So thank you.